So when we did congruent triangles, we talked about 5 different ways to prove that triangles are congruent. Do you guys remember these? Yes. So like SSS, SAS, ASA, AAS, HL. Today we're going to do a similar sort of idea, but instead of showing that triangles are congruent, we're going to show that triangles are similar. So you might be saying, what's the difference? All right. So for triangles to be congruent, that's what we did last chapter. That's when all the sides are the same, all the angles are the same. Okay? Now, the angle part is true for similar triangles too. So in this Venn diagram, I'm going to put all angles congruent in the overlapping part. All sides congruent is only for congruent triangles. In similar triangles, the sides are proportional. All right, we just talked about this. Remember, there are 5 postulates and theorems to show that triangles are congruent. There's only 3, though, to show that triangles are similar. So we're going to talk about those 3 today. All right, the first one is the angle similarity postulate. All right, if 2 angles of one triangle are congruent to 2 angles of another triangle, then the 2 triangles are similar. Basically, if two angles are the same from one to the other, the third angle is forced to be the same. So you'll see it sometimes as AAA, sometimes it's just 2 A's. All right? Again, because if 2 of them are congruent from one to the other, the sum of both is 180, so it forces that third one to be the same as well. So you can go ahead and label these. As long as you know 2 angles or 3 angles from one are congruent to the other, the 2 triangles are similar. A lot of you got this wrong when we learned the congruent one. AAA is not a postulate for congruence, just similarity. Any questions so far? All right. Side, similarity postulate. This is not the same as the last side, okay? The side for congruence, all the sides had to be congruent. And this one, they just have to be proportional. So this is what we were looking at last week when we would set up the ratio of the sides and simplify them all and see if they were all equal. That's basically this postulate, the side similarity postulate. So if you can set up all those ratios and they're all equal to one another, you know that the triangles are similar. So for this one, it would be, 10 over 5, 14 over 7, and 12 over 6. They would all reduce to 2 over 1, so they're similar. All right, so this congruent. Okay, so for these particular triangles, angle Y is congruent to angle P, and then those sides around those angles are proportional. So now we are determining whether the triangles are similar. If they are similar, we're going to write a similarity statement. We're going to find the scale factor. So we did a lot like this already. This shouldn't be anything new. Okay, so when we're doing the scale factor, that's where order matters, okay? So if the end result needs a scale factor of A to B, when I'm writing my ratios, I should start with A and go to B, okay? So if I set up these ratios A to B, the 8 goes with the 4, so 8 over 4. The 12 goes with the 6, so 12 over 6. The 10 goes with the 5, so 10 over 5. When I reduce those, they all reduce to the same thing. So all the sides are proportional. So are the triangles similar? Yes. What reason that we just learned?
Because they all equal the same thing.
What all equals the same thing?
The scale factor.
Yes. The ratio of the sides. It's going to end up being the scale factor. But yes. So this is the SSS that you just learned. That's the only new part today is this line right here, the reason. Okay? So the reason is by SSS. All the sides are proportional. Okay? Then the scale factor is just what you got when you reduce the sides. Then we're going to write a similarity statement. This is where the order matters. Okay? So if I write the first one as QPR, the next one needs to be TSU. Don't use the congruent symbol. Some of you are doing that on your quiz. Remember, there's no equal sign. It's just the squiggle part. So same type of question. We're going to determine whether the triangles are similar. If they are similar, we're going to write a similarity statement. We're going to find the scale factor, and we're going to tell why. So what information am I given in each of the triangles?
Just outside of it.
I have a side, then a what?
Angle. Side.
Then a what?
Side.
Okay, so this looks like side angle side is going to be the one that we're going for. So we need to show that the angle is congruent and then the sides on either side are proportional. So same idea as the last one, we're going to set up the proportions, except we're only going to do it twice. And then if we have the angle in the middle, we're good to go. Okay? And once again, my scale factor is going to be from A to B, so start with A each time and then go to B. All right, so the 6 and the 10 go together. The 3 and the 5 go together. If I reduce these, are they equal? Yes. So are the triangles similar?
Yes.
Yes. Do you remember what reason we just talked about?
Because it's
No.
SAS.
Yeah, SAS. We know the sides are proportional, 2 of the sides, and the angle in the middle. So SAS. The scale factor is what? 3/5. It's just that reduced ratio. And the similarity statement is what? BC. If you do BCA, then the other one has to be what? TUS. Good. That's not the way I did it. I did BAC and then TSU. But as long as yours are in the same order, like the corresponding parts are in the same order, you're good. So those are 2 examples. I think a lot of people just automatically go ABC. If you do that, that's fine. You just have to go STU. What are your questions? All right, same idea. We're going to decide if they're similar. If they are, we're going to write a similarity statement. We're going to find the scale factor. We're going to also tell the reason. Okay, so the only information I have is about sides. So I'm going to go for side, side, side and see if it works. So I need to set up those ratios. 9 and 5 go together. 15 and 13 go together. 12 and 12 go together. You can probably already see what's happening, right?
Yep. I can see everything.
The 12s are throwing us off. This would reduce to 1. So obviously these 2 are not reducing to 1. None of these are equal. So no. Once it's a no, you're actually done. I don't need the rest of that information, okay? What questions do you have? All right. Same idea. Now the triangles are just like on top of each other.
Oh, wow.
This bottom part's a trapezoid. But yes, we're going to focus on the triangle. So PRQ is the littler one. And then like PTS is the bigger one. Now, there is an angle that's in both. Do you see which angle it is?
No. QR. 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 Oh, that's QR. It's not angle.
Do you see how angle P is in both triangles?
Yes.
Okay? So I'll highlight them real quick for you. So this one has an angle P, and those are the two triangles we're talking about. Do you see how P is the same angle in both?
Yes, ma'am.
Okay? So I already know I have a congruent angle. I don't know anything about the measure of S and Q. I don't know anything about the angle measures for T and R. So AAA is not going to work. What's the other one that involves an angle? Do you remember? Side, angle, side. So if I can show that these sides are proportional, so the little one on this side and the big one, the little one and the big one, and the angle in the middle is congruent, I can use SAS. Does that sound doable?
Yes. No. No.
All right. So, if I'm looking at this side, PQ is 3, right? The corresponding side on the bigger triangle is PS. Where did the 6 come from? The 2 3's added together. Good. Same thing over here. The smaller side is PR. For the big triangle, it's just PT, which is 5 plus 5. That's where the 10 comes from. Any questions on where these numbers come from? You're just adding the sides. All right, when I reduce that, what do I get for each of them? 1 over 2 and 1 over 2. Okay?
Yes, it's the right one. Yeah.
So it is a yes. And do you remember what reason we were talking about? SAS. Side, angle, side. And the reason is that angle is the same in both. And the small segment over the larger segment, small segment, larger segment. Okay? And they're proportional when you reduce them. So 2 sides proportional and the congruent angle in the middle. All right, what is the scale factor? Where? Oh, okay. Oh, I see why we can't do scale factor. Does anyone else see it?
No.
The triangles weren't labeled. There is no triangle A or triangle B, so you can't really do the scale factor. If you didn't notice, I would put 1/2, but that's just me. The similarity statement, that's kind of tricky since they are overlapping. If you go small triangle, like top and then down to Q and then over to R, the bigger one you have to start at the P again, go down that same side, but now you're at S, and then go over to T. So that's one way to do it. Like I said on the last one, there's a few different orders that work. As long as the P's are in the same spot, the Q and the S are in the same spot, and the R and the T are in the same spot, you are good to go. Careful with your symbols, okay? It's just the squiggle, it's not the equal underneath. Questions? What are you noticing? I see a 61 and a 61 and a box and a box. What do those mean? These are right angles. Good. So 90 degrees and 90 degrees. 61 and 61. Does that sound like anything we talked about today? AA, right? 2 of the angles are congruent. from one triangle to the next. So these are similar. Yes. The reason, AA. Just like on the last one, these triangles aren't labeled, and we actually don't know anything about the side lengths, so the scale factor isn't happening here. But you can do a similarity statement. They are labeled A and B. Do you guys have side length information? Nope. So yeah, can't really do anything, even if they are labeled. The proportions that lead us to scale factor have to be side lengths. Since the angles are congruent, that's not relevant information for scale factor. All right, but the similarity statement is doable as long as you go in the same order. So like the angles labeled with the 61 would have to go in the same position. The right angles would have to go in the same position, and the F and the J would have to go in the same position. The way I did it was triangle HGF. So I would have to start with K and then LJ. What are your questions? All right, keep it going. Write a similarity statement and find the value of the variable. So similarity statement first. Triangle, what? Triangle ABC, DEF. Good. Again, not the only way, probably the easiest way. Just go in order, A, B, C, D, E, F. As long as the A and the D are in the same spot, the B and the E are in the same spot, and the C and the F are in the same spot, you are good. Squiggle, no equal sign. Now, how do we find the Y? Yeah, we got to set up a proportion and cross multiply. So 5 goes with what? 3 equals 15 over Y. Good. That's one way to do it. Another way would be, as you see on the board, Y. You can start with the unknown. If that's on the top, just make sure in the other one you put the 3 on the top. Either way you write it, when we cross multiply, we'll all end up in the same spot. Okay? So when we cross multiply, the Y and the 5 go together, the 3 and the 15. And you end up with 9 for your Y. What are your questions? All right, this one's a little trickier. You kind of have to visualize it. Pay attention to the angles that are congruent. So right here, these are vertical angles, so these two would be congruent. The D and the C are labeled as being congruent, which forces angle A and angle E to be congruent. So we could do what? If you go A, B, D, you'd have to do what? E, B, C. Good. That's one option. Here's another option. So if you start with D, so the one labeled with 1, then go up to the one that's not labeled, then go to those vertical angles. So DAB, you just have to go CEB, okay? The B's have to be in the same position. The D and the C have to be in the same position. The A and the E have to be in the same position. These questions take a long time to grade on the quizzes because there's so many options. As I'm grading them, a lot of times you'll see I'll mark right on your paper, like, kind of like follow along, like those go together, okay? Now, when I set this up, how will I set up these ratios? The 12 and the 6 go together, good. and that's this 12 and this 6. If you start with this 12, your other one would have to start with this 6 and then go to the x, okay? I'm pretty sure mine doesn't do it that way. Yeah, there's mine. So this x is where I started, and it goes with this 6. So for my other one, I had to go back to this triangle and then 6 over 12. But the way we just talked about works too, because when we cross multiply, we get the same thing. Either way, when you cross multiply, you get 12x equals 6 times 6. And of course, that's 36. And you get 3 for your y. I mean your x this time, sorry. Get my variables backwards. What are your questions? All right, so here's just a quick review. How can we show that two triangles are congruent? We talked about them twice already today, and we spent the whole last chapter discussing them. What are the 5 ways you can show that triangles are congruent? Yes. All the sides are equal. Good. So we will call that one SSS. Is there a similar one that works for similar? So to show that all the sides are congruent, you can show the triangles are congruent. How do you do that with triangles that are similar? Or do you just want to do all the congruent ones first? All the congruent ones first. Okay. So side, side, side. What's another way? Side, angle, side. AAS. AS. Nope. ASA. Good. Then there was a random one that didn't have any A's or S's in it. HL. Very good. So these all have to be congruent. All the sides congruent, a side angle side congruent, an angle angle side congruent, angle side angle congruent, or hypotenuse and leg congruent. All right? And those show that the two triangles are congruent. Today you learned 3 ways to show that triangles are similar. What were the 3 ways? AA. Good. And I'm just going to put in parentheses that both angles had to be congruent. Okay? What's another one? SSS. And they're not all congruent, they're all what? Proportional. Good. And what's the last one? It's kind of a combination. What is it? Good. And the angle has to be what? Congruent. And the sides have to be what? That's kind of weird. Look. The sides have to be proportional. Okay? So it's a kind of... Especially these two, they look like they're the same as over here, but they're really not because the sides aren't congruent, they're just proportional. All right, that is the end of our notes for today. I'm going to bring you your homework.